Hello there and welcome. In the previous episode we started working on the state machine of our bear. So this bear will be our first enemy, but it can also just be any kind of animal or NPC in your game. So we completed the idle state for this bear and now we started working on the walk state. So we're going to open this script and add the code. So the fields that we're going to have inside this state are a timer and a walking time float. So this will basically allow us to make the bear walk for a certain amount of time. And when he will walk for 10 seconds, then this timer will be up and he will go back to the idle state. Okay, so he will be idle for a certain amount of time. And then when he enters into the walk state, he's going to walk for 10 seconds and then he's going to return to the idle state. So you can change the amount over here. And of course, you can also do that from the inspector. Then we have a reference to the player and we have a reference to the navmesh agent. Because as I told you, we're not going to use some kind of primitive script for the movement. We're going to use the AI navigation components. So we need a reference to the agent because inside of this walk state, we are actually going to move our bear. Then we need a float that will be the detection area. And you can see that it's 18 because this is the same thing we have in our idle state. Inside the idle state, we have this detection area radius 18. So this is basically the area where the bear is going to detect our player and start chasing it. So if it's easier for you, you can simply copy this and give it the same name so you won't get confused because it's basically the same thing. But over here, it will be triggered from the walk state and over here, it will be triggered from the idle state. Because if you remember from the previous episode, we can go to the chase state from the idle state and from the walk state. Then we also have the walk speed that will control the speed of the bear when he's walking. And we are also going to have a list of transforms that will be the waypoints. So these waypoints are going to be positions that we're going to set around the bear so the bear will know where to go to. So this navmesh agent will know where to go. And he will go to these waypoints when he's inside of this walk state. Now inside the on state enter, this is basically what will happen when he first enters into this state. We're going to get the references for these things, for the player and for the agent. We're going to set the timer and we're going to set the speed of this agent. And then we're also going to send this bear to the first waypoint, and then he's going to basically go from one waypoint to the other. So we get the references for the player, and as I told you, because we cannot drag references into the inspector with these state machines, we have to find the player using the find game object with tag by setting a tag on the player. And remember, don't use the find game objects, but use the find game object. And we are also going to get a reference to the agent, and we can do this by getting this animator that we are passed inside, and then we simply get the navmesh agent of this animator. Now we are also going to set the agent speed to the walk speed, and we're going to reset the timer to 0. Then we're going to basically get the waypoints cluster by using this find game object with tag again, and we need to create this tag and set it on the waypoints cluster that we're going to create. And then we basically loop over each one of these waypoints and we add them into the list. And then we find the first position and we also make it random. So it will find the first position and it will move the agent to this position using this set destination method that is a part of the AI navigation. So he will basically move to the first position when he first enters into this state. And then inside the update state, we are going to keep moving from one destination to another, from one waypoint to another unless he detects the player, and then he's going to attack or chase the player. So let's add a code for this as well. Over here, we can simply copy this entire code from our idle state. So over here, where we check the distance from the player, we don't have to do this all over again. We can paste it inside, and now we can check the distance from the player. Just if you have a different name for the detection area, then set it over here. But we use the same name, so it will be the detection area radius. And over here, we keep it at is chasing true. So basically, if the distance from the player is smaller than the detection area, we are going to start chasing the player the same way we did it in the idle state, okay? And over here, as I told you, we're going to increase the timer and check if the timer is bigger than the walk time. If it is, we're going to basically move back to the idle state because this will become false. And we also want to move from one waypoint to another. So if the agent reached his destination, basically his waypoint, then he's going to get another random waypoint and move to this random waypoint. And this time we also want to add something into the onState exit. We basically want to stop the agent from moving, because when we exit this walk state, we want him to just stay still and be inside of this idle state, right? Because in the idle state, he is not moving. So agent set destination, and by simply giving the exact position of the agent, he will basically just stop and not move. And this will basically make it much more smoother. Otherwise, when we exit this state, he will still try to move to another waypoint, and the walk animation is not going to play, but he will still move. So that's why we're doing this, so things will not look weird. Now we're going to open our chase state. So we are done with the walk state. We're going to open the chase state. So we have these fields, again, a reference to the player, to the agent. We also have a chase speed, because the chase speed should be faster than the walking speed. Then we also have this stop chasing distance, and this will basically be the area where the bear stops chasing the player, right? And this should be a bit bigger than the detection area. So imagine the bear is detecting the player at 18, and then the player starts running and he actually escapes the bear, and now the distance is 21. So the bear is going to stop chasing it, okay? So this value should always be bigger than this value. Then we also have the attacking distance. So when the bear is in the chase state, if he gets very close to the player, he's going to start attacking it, right? So we need this attacking distance as well. Then, as usual, we get references inside the onState enter, and we change the speed to the chase speed. Now we're going to do all the checks we need inside the update method. Over here, we set the destination of the agent, which is the bear. We are going to set it to the player position, right? Because when the bear is in the chase state, he should start chasing the player. So this is what we do over here. We also want the model to always look at the player. So we use this built-in method, look at player. Then we get the distance from the player, and we check if the distance is bigger than the stopping distance, then stop chasing. And if it's smaller than the attacking distance, then start attacking. So this will check these two things every frame. when he's inside the chase state. And inside the on-state exit, we're going to do the same thing as we did over here inside the walk state. We're going to basically stop the bear, because when he starts to attack, he should just be still and not walk. Now, this can be a bit tricky depending on the NPC. Maybe he can attack while chasing, so you should not stop him. But in our case, when he enters into the attack state, he should just stay still, especially if he uses some kind of close ranged attack, right? And this is again something we need to do to make things look better. Of course, with your different models and different NPCs or monsters or enemies, you can play around with this. You can, of course, add more things. This will not work for all of them. You need to actually understand the code and understand how to use this. Now we're going to open our final state, which is the attack state, and we're going to add a few fields. We're also going to add the references, so we can simply go over here and copy this. Then inside the onUpdate, we're going to call a method that we're going to create in a moment, look at player. And this is not the same as look at, right? Because this is a built-in method that uses this transform to look at this transform. But this is another method that we're going to create that will do things differently. So when he attacks, he still needs to look at the player. Okay, so this is something we're going to create. We can also generate this over here, or maybe over here. And then we're also going to check. And again, because things are very similar, we don't need to write everything down. We can simply go to our walk state and copy this thing over here and paste it. And then we simply need to change, let's see, if the distance from the player is bigger than the stop attacking distance, then we want to set is attacking to be false. So when we are inside of the attack state, we always want to check if the player is outside of the attacking distance, and then we're simply going to stop attacking. And when we stop attack, right, when we stop and we use this false bool, then it will basically go back to the chase state, right? Because we set it over here. If attacking is false, go back to the chase state. Now inside the onState exit, we don't really want to do anything right now, but we want to create this look at player method. So over here, we simply want to rotate the bear to the position of the player, but we also want to set the Y rotation to 0, because if, for example, our player is higher, we don't want the bear model to rotate up, right? We still want it to be flat and we want it to look straight. So we are also going to set it to 0, especially on the Y axis. So that's all for the attack state. Let's go back to our idle state and let's just set the idle time to 4. Obviously, we can do this from the inspector, but it's good that we have some kind of default value inside. So the idle time will be 4. Of course, you can change it. For the walk time, we're going to set it at 10. And now when everything is saved, we will return to this animator screen. And if we click on these states, we can see that we have public fields over here. Now this is still at 0 because we did not refresh it, so let's just refresh. We cannot reset, so let's just put it at 4, but this should basically be this value over here, right? So the idle time is 4, the detection area is 18. Over here, the same thing, detection is 18, walk speed is 2, walking time is 10, chase state, this is the speed, this is the stop distance, and this is the attacking distance. And then we have the stop attacking distance. This should actually be different because the stop attacking distance should be a bit bigger than the attacking distance. The same way the stop chasing distance should be always a bit bigger than the detection area radius, right? We can also change the attacking distance to something bigger, for example, 7. And then we simply set this to 7.1. Of course, you need to play around with this. It depends on the size of the bear. It depends on the size of the player's model. So it depends on many things. You need to play around with this and fine tune it. Now we also want to create the waypoints cluster that we talked about. So inside the scene, we're going to, let's just dock it back over here. We're going to create an empty game object and we're going to name it waypoints cluster. And because we use this over here, right, and we searched for it with this tag, we need to create this exact same tag. So we're going to create a tag with this name, waypoints, and we're going to set it on the waypoints cluster. Now inside we're going to create a sphere and we're going to make it a bit smaller, so 0.5, and we're going to lower it to the ground. So it should not be under the ground and not in the air, somewhere over here. So this will basically be the position the bear should walk to. Then we're going to move it over here and we're going to duplicate it a few times and move it around the bear. Now we can also select all of them and remove the sphere collider and also remove the mesh collider because we want them to be invisible. They still exist, but they're simply invisible because we don't need to see them. So now the bear will walk from one waypoint to another, randomly selecting the next waypoint. Now, you may already notice that this is something static, so it will always be in this spot. So if the bear is chasing us and we run over there, he will return to this spot instead of just walking around himself. So for this, you can simply take this entire waypoint cluster and drag it as a child of the bear. And now it will be relative to the bear. So you can also zero it, let's reset it, and let's also make this visible so we can see that you can see it looks a bit weird. So let's just position it over here and we can change the different positions. Now it got big because it's a child of the bear. Let's find the other ones. So it really depends if you want to make it static or you want each NPC to have its own waypoints. Okay, so this means that if he's going to run after us and then stop chasing us, he will just walk around these waypoints. And let's find the other one over here. Now you may still want to adjust it and play around with this, but now we can make it back into invisible and he will basically look for this and walk from one waypoint to another. Now you are going to have a problem because this waypoints cluster uses this tag, and if you're going to have more bears or more animals and they will all have this waypoints tag, then he's simply going to walk and follow other waypoints that are not even related to this bear. Now obviously you don't want to create, let's say, waypoints bear 1, waypoints bear 2. This is not effective. So you simply can create some kind of reference to these waypoints. For example, you can add a component named waypoints, let's say NPC waypoints. And inside we're simply going to have a reference public game object NPC waypoints cluster. Okay, and then we're simply going to have a reference for each one of these NPCs. So each NPC will have its own cluster. So now we can simply drag this into this NPC cluster. We can remove the actual tag, right? We don't need this tag anymore because we have a reference to this cluster inside the NPC. And then inside the code, inside the state, instead of looking for a global game object with this tag, we can simply say animator, because this is the way we can get a reference to our NPC animator, get component, NPC waypoints, which is this component. And then we're going to get the NPC waypoints cluster. So it's going to get the cluster for this exact NPC, okay? So with this change, it will only follow its own cluster. Now, I don't know if this will work perfectly, but this is just an option. And of course, you can keep it the way it was before. It can be static over here, especially if you have some kind of maybe guard that is guarding a door. So even if this guard is chasing you and you run far away, you still want this guard to go back to this gate, right? And you want him to still guard the gate. So you want to create static waypoints near this gate, right? You don't want the guard to just start walking around some kind of area. You want him to go back to this gate. So it really depends on the NPC. For a bear, I think it's a good thing to put it inside of the bear, because even if he runs away, he should always start walking around himself. And it really depends on the game. Maybe you want the bear to go back to this area, and if you kill the bear, then another bear will spawn later. And we're also going to talk about spawning enemies after a certain amount of time. But maybe you want the bear to always spawn at this area, and if he chases you, then you want him to go back to this area or something like that. So this may not be the best idea. So it really depends on the NPC. Now, in order to make this NPC, this actual model, walk around the world using the NavMesh component, we need to add a NavMesh agent on this bear. Now, it really depends on the version of Unity you are using, because in 2023, they changed the way the AI navigation is working. It works basically the same way, but it's a bit different. The menu looks different. So we are still using the very old 19 version for Unity. And of course, you probably created a newer version and you're using the newer version, because things should still work fine. And I'm always afraid to change it to the newer version because maybe it will break something. Maybe later I'm going to convert this entire project into a newer version. But for now, this works. So if you're still using this old version, this 2019 version, then all you need to do is go to Window, AI, and you will have this navigation option. And then you will get this navigation menu. You will simply click on your environment terrain, and you will find this exact terrain, this one, and you're going to see this navigation. So you simply need to bake it. You click over here, bake, and then you will see this blue outline on all of this area. Now, if you don't know how to use NavMesh surfaces, it basically creates this area that the agent can walk upon. And these parts over here are not walkable, okay? Because we have other objects. Now you can change the slope, you can change the agent height, so it will change the way the agent walks. For example, if you have stairs or this thing over here, maybe you want the agent to skip this part, or maybe you want him to go up the stairs. So you can play around with these slopes and things. But eventually you're going to bake and you're going to see this. Now, if you don't see this blue thing, it's just because your gizmos are not enabled, right? So enable the gizmos and then you're going to see it. Now, if you are using newer versions of Unity, so 2023 and up, then things will look a bit different. For this, you will have to add the AI navigation package. You will go to Package Manager. It probably will be found inside this Unity registry. It will simply be named AI Navigation. You're going to import it, install it, and then you're going to get a bunch of components. So what you need to do is basically add the surfaces on the actual terrains that you want to work with. So it's going to be different. Now, if you want to know how to do it exactly, then you can watch my RTS tutorial. I'm going to have a link in the description for the exact episode where we add all of this. So I don't remember exactly which episode, but I'm going to add a link to this episode. Over there, we use the newer version of Unity, so I show how to exactly add this. But you will basically click on your terrain and just make sure that it's the terrain that is relevant. For example, this one. And then on this terrain, you will simply add a component named something like nav mesh surface or something like that, surface. Okay, so you will get this component by importing the new AI system, nav mesh surface, and then it's going to add this component. And the same way, you can just bake it. And after you bake it, you're going to see this blue area. And it means that the bear is only going to walk on this blue area. Now, you also need to add a navmesh agent on the bear, right? Because inside the scripts, we're using this agent, this navmesh agent. So it doesn't matter if it's the new version or the old version. All you need to do is click on your NPC and add navmesh agent. So this will basically allow your model to become an agent and to actually walk around. And of course, there's a lot of different settings over here. You can control the speed of this agent, but as you know, we changed the speed from the code. Remember, the walk speed and then the chase speed. So all of these things can be customizable, but just see how they work for you and then you can change them. We are going to leave it as it is, but now we have this navmesh agent on the bear, and if we start the game, it should already work. Now, if you want to troubleshoot this, if you want to debug this, if you want to play around with the different distances, we're going to create some kind of script that is going to visually show you the positions where the bear is going to detect the player. So we are going to have our bear, and inside we can create a separate script, NPC gizmos. Inside the script, we're going to have a method named private void on draw gizmos, and this is a built-in method that comes with Unity that basically creates gizmos that you can debug later and see them inside your game. So we're going to add a few different gizmos. Okay, so by creating these gizmos and providing the different distances, so this is basically a radius because we're creating a sphere around the bear, and then we're going to use this distance to create some kind of colorful sphere that is going to indicate this area, right? So these values should be the values that you use inside of your animator, right? So for the chase detection, we have 18, and that's why we use 18 over here. For the stop chase, we use 21, so we set it over here. And for the attacking one, we use 7, and we set it over here. Of course, you can add another one for the stop attacking distance, right? And say 7.1. But because this is not a big difference, you should just keep it this way. It will be cleaner. And now when we have this, it will basically show us these spheres when we run the game. And we can know. You can see right now inside the scene, these are the areas that we created. So when the player is going to enter into this green area, or actually into the blue area, then the bear is going to start chasing it. If the player gets out of this green area, then the bear will stop chasing it. But if the player is inside this red area, then the bear is going to start attacking him. And this is good, because this will help you with the debugging. Now we can start the game, and we cannot see it in play mode, but you simply need to start the gizmos, and now you're going to see it. So when we enter into this blue area, the bear is going to start chasing us. And you can see that the bear is chasing us. But if we exit this green area, so if we are faster than the bear, he's going to stop chasing us. And now he is in the idle state. Now he is in the walking state. So he simply moves from one state to the other. We can also go to the animator and see idle state. Then after 4 seconds, he will go to the walk state. he will stay here for 10 seconds and then go back to the idle state. So we can get closer, and now we will run after us, and when we enter the red area, he's going to attack. Okay, so now he attacks. When we run away, he's going to continue chasing until we enter into this area, and now he's going to attack. And of course, at this point, we have no damage, we have nothing else, we don't have any sounds. But when we add damage, when we add sounds, things will look and feel much better. And of course, this is a very basic model. You can create much more complex things, but you can see that with this state machine, it's very easy to control all of this. So now the bear actually has his own brain and he will know what to do. Of course, we can add morph states and we can add random animations, we can add sounds, we can do whatever we want inside of these scripts, okay? Another thing you should know is that with the new system, so if you're using a newer version of Unity, it's not going to detect these obstacles. For example, you can see if we click on the environment and we go to navigation, you can see that when the bear is going to reach this bench over here, he is not going to walk because it's not blue. But with the newest version of Unity, you should specify each object that is going to be an obstacle. And you can do this by simply clicking on this object and adding a component named navMeshObstacle, okay? And when we set it as an obstacle, the bear will basically not walk over it and he will treat it as an obstacle, okay? So this can be a box or a capsule. So this is the new way you do it in the newest version. So if you have some kind of tree in the middle of nowhere, you can simply add this navMeshObstacle and then the bear will ignore it and he will not walk through this tree, okay? He will just walk around it. Now, why this obstacle is also a good choice? Because imagine you have a tree over here, okay? And this tree is an obstacle. But if we don't use this obstacle component and we use this regular navigation, so the tree will have this area over here around him and the bear won't be able to pass through it. But then what happens if we cut down this tree? If we cut down this tree, it will still have this unmarked area. So the tree will not exist anymore because it will be cut down, but it will still have this unwalkable area. But if we add an obstacle to the tree and the tree is destroyed, then the bear will be able to walk because the obstacle will be destroyed with the tree. So that is the difference, okay? Of course, in our case, when we cut down the tree, it still has the stump, right? So it will still be here. But for example, we have a house or maybe some kind of, let's say, another bear. So maybe you want your bears to also have a navMeshObstacle so other bears won't be able to pass through them, right? So you add an obstacle to the bear. And this way, when the bear is dead, there will be no more obstacle. Okay, so you can play around with this. And this is just an option. So sometimes you will have to add these obstacles to dynamic things. If these are static things like houses, then okay, you can use this because the house will always be here. So this area should not be walkable anytime, right? Because the house will always be here. But for other dynamic stuff like breakable things or other NPCs, you want to add obstacles. So that's all for this episode. Now, we are still not done with this animal and with this NPC. We still need to actually enable damage. So when the bear is going to attack us, the player will receive damage. So we need to add a damage system so the player can receive damage and the player can also die and spawn again. We do have a health system, right? The player has this health bar, but there is nothing that can actually damage us. So we do want the damage that the bear does to decrease the health of the player. And we also want to actually attack the bear. Okay, so you want to be able to attack the bear. Of course, in order to attack the bear, we need to create some weapons. So we're going to create some weapons. Maybe we're going to start with a bow and an arrow because a lot of you ask for this. So we're going to create a bow that we can craft and also arrows, and then we can use these bows and arrows. Maybe we can also create swords, and then we can attack the bear and we can kill him, and then we can loot him, or maybe just some meat will appear on the ground and we can take this meat. We also want to add some sounds to the bear, so there's a few things that we want to do in the next episode. So thank you for watching. Please subscribe if you're still not subscribed. Please leave a like for the algorithm. And of course, if you have questions, ask me in the comment section, and I'll see you next time.